Good evening, everyone.
Good evening, sir.
So before joining everyone, a small activity for everyone who are here. In the last class, we discussed about the mirrors. Am I right?
Yes, sir.
So just write the brief uses of concave mirror and convex mirror. Immediately post in the group. 5 minutes.
Sir, only uses, sir.
Uses of concave mirror and convex mirror separately. At least 3 points for 3 to 4 points for each, and post it.
Okay, sir.
Good evening, sir.
Good evening.
Sir, I just now joined. What should we do?
A small activity before entering the class about revision.
Okay, sir.
You have to write a brief points of uses of convex and concave mirror.
Okay, sir.
Has anyone joined newly? Akash?
Sir,
Yes, write the uses of convex and concave mirror and post in the group. Or send it to me personally. Don't need to post in the group. Sorry. Send to me personally.
sir, what?
We are going to do all these activities. Sorry?
Sir, what we should write, sir?
Write the uses of convex mirror and concave mirror.
Oh, okay, sir. Okay, sir. Okay, sir.
3 points each minimum.
Okay, sir.
Guys, whenever writing the answers, there's no hurry. It's not a race. First of all, keep it in mind. I'm not talking about who submitted first and who submitted last. For me, everyone is Even if they submitted with 1 hour gap or half an hour gap, I feel same. I need only the proper presentation. And you have to decide what kind of answers I have to write in points, what kind of answers I have to write in words, like single word or 2 words, or what kind of answers I have to write single statements. So keep it in mind before writing the answers. Certain answers we won't consider much, even though if it is very accurate answers, we will cut a half mark or 1 mark. So I'm not saying me, I'm saying we in the sense the people who is sitting in the examination, like the correction hall. So we 25 set people we will call as a team. They will go for corrections under one supervisor. So keep it in mind when you are reaching almost accurately 100%. We will try to like look into the paper very like we will expect more accurately. So definitely, if you caught somewhere, half mark, 1 mark will reduce. So you have to decide properly. Once you are good in the content, so presentation you have to focus. So no need to worry when you are giving the answers. So 1 word or 2 words, just make it as a statement whenever we are talking about the uses. Is it clear what I'm saying, guys?
Yes, sir.
Not mentioning any one particular person here, just I'm saying overview. What kind of mistakes generally we will feel, who is getting the difference between the person who is 95 and 100, 98 and 100. That means the person who got 100 is very good and 98 is slightly lesser than him. It's not like that. Small things will make them differ. I asked 3. Somebody wrote only 2 for convex. See, whenever you are unable to remember, try to recollect the practical scenarios in your daily life when you are going somewhere and we are moving around a shopping mall. So many places you can see the mirrors. Definitely you can get some ideas, or you try to recollect what we discussed in the class. Shall we discuss answers? So what are the points you are not written? If some others are wrote, we can able to like share. This is one kind of exercise we'll call as a sharing the knowledge. Might be my answers are not tallying with your answers. Your answers are not tallying with my answers, but all the answers are same. Particularly when you are writing the differences, uses, characteristics, drawbacks, comparisons. These are the different questions where different students will write different answers. So whenever you are sharing with your friends or with even though in school, if you are sharing your answers with others, you can gain a lot of knowledge. Is it clear what I'm trying to say?
Yes, sir.
So I don't want to call out the names, just I will read out the answers written by you people. The one which I received very just now. Uses of concave mirror. The mirror are commonly used in torches, searchlights, and vehicles headlights to get powerful parallel beams. It's good. Concave mirrors are used as shaving mirrors to see larger range of face, and dentists use concave mirrors to see larger images of teeth of patients. Good. Nice explanation. Convex mirrors are commonly used as a rear view mirrors in vehicles because of they always gives the erect image and have wider field of view as they are curved outwards. Correct. Big convex mirrors are used as a shop security mirrors. The shop owner can keep an eye on the customers to look for thieves and shoplifters. Convex mirrors are used to for magnifying glasses. How convex mirrors are using for magnifying glasses? Anyone? can justify this statement? At least the person who wrote can justify this statement. I am able to get this statement. Guys,
Sir, in order to make the magnifying glasses, two convex mirrors are placed back to back, sir.
where you saw like this? I don't think so. Mirror is different, glass is different. Am I right?
Yes, sir.
Okay, I will discuss with you separately. It's not right answer. Don't think like this. If you are using like that, you will get a double-sided mirror. That's it. You won't get a glass. So one more answer, commonly used in searchlights, same. Shaving mirrors and dentists, same answer. There is no different answer. Commonly used in rear view mirrors, shop security lips, used in magnifying glasses, again same. How magnifying glasses you are using? How it will be useful magnifying glasses? Don't mention magnifying glasses. When you mention the glass, it will comes under like a lens. So you use a different word. Clear what I'm trying to say?
Okay, sir.
Yeah. So don't use glass. Glass is like a transparent medium. So one more, same answers: dentist, shaving mirrors, torches and lights, rear view mirrors, security mirrors. Yes, there's no different answers of found within you people. Yes, even the first answer is magnifying glasses, same. See, is your magnifying glass in your laboratory is a mirror or glass?
Glass, sir.
Hmm. But I'm talking about convex mirror. So keep it in mind, guys, when you're writing the answer, sometimes careful. When you're almost reaching 99, 98 marks, these points will be validated. In side view, security, correct, vehicles, shaving mirrors, correct, enlarged image of the face and of the dentist to see the bigger images. So split the whole paragraph into lines. Uses, characteristics I already told. Please write in the form of lines. Shall we move for one more activity like this? See, this is one kind of question frequently asked in so many board examinations. We can go for one more activity, guys. I don't think activity means something out of the academics. Yes. So quickly, please draw the ray diagrams of a convex mirror and concave mirror and just post it like this. Everyone, I am expecting all 1, 2.
Sir, all the types, sir, for convex and concave.
Yes, total 8 diagrams will come. How
Okay,
much
sir.
time you want? How much time you want? 1, 2, 3, 4, 5, 6, 7, 8. I need 8 answers. I need, because every time whatever you see old papers, each and every time they asked something related to ray diagrams. They never left the ray diagrams. At least some minimum marks you can expect from the ray diagrams. How much time? Don't write for too much accuracy because I'm giving less time.
Sir, both concave mirror and convex mirror, sir.
Yes, both concave mirror and convex mirror, all the possible ray diagrams. Total
Sir,
8 diagrams will come.
Position, nature, and all needed, sir. Like
I need ray diagram is enough. In the
Okay,
diagram
sir.
itself, you can explain the what is the image, measure I need, what is the image, what is the object, the way how you will draw, that will decide it is inverted or real or anything, correct?
Yes, sir.
Yeah, so that's enough. I can understand, because if you are able to draw the ray diagram, it's not so it was not so big deal to write the data, like whether it is inverted or whether it is real or virtual or all the things, correct? If it is upside down, it's inverted. If it is behind the mirror or same side the mirror, that will give the virtual or real. So automatically I can understand if you are drawing the ray diagram. So don't mention like what it is erect and all. Just mention what other thing it is in there. I need ray diagram. Where is your image? Where is your object? That is enough. And our basic things: focus, center of curvature, and pole. Quick.
For both concave and convex image
Yes.
formation.
Both concave and convex images will be up. That's the
Okay,
reason I'm
sir.
asking how much time you want. Commonly, I'm asking how much time you want. Sandhya,
10 minutes.
10 minutes is fine.
Yeah, okay, sir.
Yeah, 10 minutes, quick. Please write your names. I want to know how many people submitted, because one of the important topic related to this n number of questions they may ask. So don't think in examination they will ask all the ray diagrams. Sometimes they will ask only the particular ray diagrams.
Guys, anyone shared the answer?
Sir, I will send the concave mirror,
I
sir.
also sent, sir.
But I didn't receive any messages. Just hold on a minute. Yes, sorry. It's good, everyone. As of now, only 3 answers. See, next time onwards, now we are having one idea how to draw the ray diagrams. Take a white paper, A4 size, and try to draw all the 6 ray diagrams in a single page, like a tabular column. Just try once. Initially, it will be little tough. Once keep on practicing, it will be very easy. It will be useful a lot in our examination to complete little bit fast. Got it? What I'm trying to say?
Sir, but it may look little messy.
That's why you have to manage how to avoid without messy.
Okay, sir.
Or at least 3 diagrams in a single page. You can use left side page, right side page, all 6 diagrams in a single shot. Got
Right,
it?
sir.
At least 3 diagrams in a single page. So left side page, right side page, in a single view, you can able to see the whole 6 diagrams. Practice, only by practice it will come. Maybe first 3 or 4 times it will be mess, but 5th time you know how to handle the answers without mess. Clear what I'm saying?
Yes, sir.
Yes, sir.
It's good, everyone. Excellent job. Yes, now I'm sharing the screen. Guys, I can proceed. I will wait for some time for others. 1, 2, 3, 4, 5, 6. Only 5 answers as of now. I will wait for others because I received only 5 answers. 1, 2, 3, 4, 5. I will wait for others for a few minutes. Just raise the hands. How many are submitted? Just raise the hands. There are some in chat options. You can have some expressions or something.
Sir, I have submitted concave, sir. I am doing convex now, sir.
Okay, okay. Then I will identify who is not submitted. So it will be easy to proceed to the next topic. After this, I am entering to the lens.
Sir, I have submitted concave.
Akash, you submitted anything? Amrita?
So taking support of 1 minute, sir.
Okay. We'll wait. Sandhya, what about you? Nirupama?
Sir, almost done, sir.
Yeah, okay. Don't rush. See, look into the time. Minimize because you have to attend all the other questions also in examination. Who just sent recently?
Sorry, sir, I forgot to write my name. Amrita.
Sorry?
Amrita, sir.
Okay. Raise the hand. Yes, I will know how many are submitted. See, meanwhile, rest of the people can work out on these things. What are the things you can able to recollect by seeing these questions, these names? Who already done? For those, this is an exercise. What are the things? These are the things we are going to discuss. Most of, except ray diagram, everything we are going to cover. What are the things you can able to recollect, and what are the things you are unable to recollect? Suppose the any questions asked on these 9 topics, how many of people can able to answer? Can able to see the screen?
Yes, sir.
Yes, sir.
I want to increase the font. That is enough. Can able to read?
Yes, sir.
Yes, sir.
Can read, sir.
Little important. Whenever if you are feeling tough paper, how many people can able to answer the last 4 questions or last 5 questions? Genuine answers I want. I'm not asking you to give the answer. Just I'm asking yes or no. Yes, sir, I can able to answer. No, sir, I can't. How many?
Fifth question is factors affecting on refractive index or factors affecting, sir?
Sorry?
Sir, fifth question is affecting or affecting, sir, the factors.
Affecting.
Okay, sir.
Maybe spelling mistake.
Answer, sir.
Yes, sir, I can answer.
All the things.
Yes, sir. Yes.
Yes, sir.
Affecting, not affecting. Effective is different. Affecting is different. Yeah. So anyone can give the answer for 9th question? Who can give? Guys? Anyone can answer? Anyone can discuss the question? Suppose if there is a question for 2 marks, write the relationship between a refractive index of a medium and frequency of light in that mediums. Niranjan, any idea about this answer?
Sir, thinking, sir.
Yeah. Okay, anyway, I'm coming from beginning, which will cover all my discussion will cover all these things. We'll see whether we can complete within the time or not. And just I'm going a little bit fast. Wherever you are not getting or you are unable to understand, guys, don't hesitate to ask. Like, please ask me to stop, and I will discuss again. Not a problem. First one is concept of refraction. Any idea for anyone? What is a refraction?
Sir, the bending of light ray when it passes from one medium to another medium, sir.
Yeah, bending of light ray when passes from one medium to another medium. That means if it is passing from air to water, this is a normal. The light ray is entering here. The blue color says light ray, dotted shows normal to the interface. This is the interface, the boundary between the 2 mediums. If there is no change in medium, the light ray will travel like this. I will show with colors. So the light ray will travel the black dotted line. So there is no difference in medium. But the medium is different. There are only two possibilities. According to this, the light ray can bend towards the normal or away from the normal, depends upon the mediums. In this case, the light ray will bend towards the normal. The angle between this is called incident ray. This is called refracted ray, which bends towards the normal.
Why the refracted ray is bending towards the normal when it passes from a rarer
Due to
medium?
the change of speed in light. Due to the change of speed in light. This is angle of incident and this is angle of refraction. See, whenever it is entering, see, so whatever the discussion I'm giving, it will come. It will come in fourth point. Let's see. Just as of now, it's a nature of light. Was only they observed this thing is happening practically, but when it looks into why it is happening means a few mediums which will slow down the light. The light was the speed of the light is maximum only in vacuum and air. Almost all both are same. So why it is bending, I will explain you. It is out of the book concept, guys. It's completely related to wave optics. Anybody can able to recollect when I'm discussing the concept of wave optics and ray optics in the beginning. The study of light in two ways we studied. One is the light is traveling in a straight line. Whatever the question you are asking, why it is bending towards the normal or away from the normal, the ray optics will not give the any conclusion. Only practical way only we can say. But conceptual way, if I want to say, or theoretically, if I want to give any explanation why it is bending towards the normal or away from the normal, if I'm introducing the wave optics, it will be easy to understand. Is it clear what I'm saying?
Yes, sir.
So we'll discuss that one is later. Now, what are the laws of refraction?
The incident ray, the refracted ray, and the normal of two transparent media at the point of incident all lie in the same plane.
In
The ratio of angle of incidence to the angle of reflection of light is
it's called refractive constant. That constant is called refractive index. Correct?
Yes, sir.
Sin I by sin R will be equal to refractive index of second medium with respect to first medium. In this case, refractive index of water with respect to air. Suppose if I'm doing the same experiment, the light ray is entering from water to air. What they observed is the light ray is entering like this. This is incident ray, and the dotted line shows the normal. Instead of going straight like this, it is bending away from the normal. It is bending away from the normal. This is the incident, and this is called refraction angle here. So what they observed is optically denser medium. They decided whenever light ray is entering, one is optically denser and one is optically rarer with respect to each other. So that will explain the refractive index. The absolute refractive index will explains the absolute refractive index of a medium is explaining when the light ray is entering from air or vacuum to that medium. That is called absolute refractive index. Suppose if it is entering from water to some glycerin or some alcohol or methane or some other liquid. In this case, we are not calling as absolute refractive index. So what it will makes, why it is bending? What observation they found first was they gave the relation between speed of the light. The refractive index of a, suppose if the light ray is entering from air to water, for example, it will bend towards the normal. This is in angle of incident. This is refraction angle. This is actual path. This is refracted ray. How actually refractive index was defined? The refractive index of a medium with respect to air or vacuum can be defined as speed of light in air or vacuum. C divided by speed of light in that medium. So velocity of light in medium. What they observed is whenever if a light ray is passing from one medium to another medium, definitely there is a slight variation in the velocity. So the velocity is decreasing. This ratio is explaining how many times the speed of the light in vacuum or air will be equal to how many times speed of light in that particular medium. This is a constant. This constant is called refractive index of that particular medium. Is it clear? Suppose if I'm saying the refractive index of a glass is 1 point. There are different glasses. I'm taking general glass and ordinary glass. The refractive index of a ordinary glass is 1.5. The meaning is the speed of the light in air or vacuum is 1.5 times of the speed of the light in glass. Is it clear what is the exact meaning of the refractive index? After that only Snell's doing some experiment, they found the relation between angle of incident and angle of refraction. Is it clear?
Yes, sir.
Yes, sir.
Now, how I can relate the speed of the light to my frequency and wavelength? Now, one point we have to keep it in mind before going to the topic. It will come in wave concept of 9th standard. We know the velocity of a wave wavelength by time period, whether it is a longitudinal wave, transwave, or frequency of the wavelength wave into wavelength. Will you agree with me?
Yes, sir.
But light is an electromagnetic wave. This electromagnetic wave, the frequency is depends upon only source. So automatically, whenever the light ray is entering in some other medium, the frequency always constant in any medium for a light. So frequency will not affect even if the light is passing through water, passing through alcohol, passing through turpentine oil, or passing through diamond, passing through ruby, or whatever material you're taking, the transparent material, the frequency of light doesn't change. It is purely depends upon the frequency. But the lambda of the wave will change. That is the wavelength of the wave is changing whenever it is entering into some other medium. So the lambda is changing and frequency remains constant, means it is slowing down. It is changing its velocity, but actually the highest speed they found as of now is the speed of the light is maximum in only in space. So first, the order of the learning is in textbook, refractive index of a medium is sin I by sin R, and speed of the light in vacuum or air by speed of the light in medium, that is frequency in space or in vacuum, and lambda in vacuum divided by frequency in medium and wavelength in a medium. So frequency is remains same. It does not affect even though mediums are changing. So the relation between refractive index of a medium is wavelength in vacuum to the wavelength in a particular medium. Suppose if I'm saying the light is entering from air or vacuum, because both the refractive indexes are same. And it is entering to some other water. So refractive index of water will be equal to lambda in air or vacuum divided by lambda in water. Is it clear? If the wavelength is increasing, speed of the refractive index will be decreasing. If the wavelength is decreasing, refractive index will be increasing. So based on this, there is a question they asked. A light ray of two colors, violet and red color, entering in air to water, which will have more refractive index? Which color will have more refractive index? Anyone? Which color will have more refractive index?
So violet.
Why?
Sir, because it has less frequency.
Frequency doesn't matter. Who told violet is having less frequency? Frequency is same
Sir,
for violet and red.
Sir, it bends more than red.
Sorry?
Sir, violet color bends more than red.
See, violet color is also a electromagnetic wave of light. Red color is also electromagnetic wave of light only. I'm getting same source, violet and red, coming from a single source. Frequency will same, only the wavelength will be different. Red is having more wavelength.
Sir, violet will have the maximum refractive index, sir.
Correct. Violet is having less wavelength.
Because it has least.
That's the reason for long ranges distances you can see only red color. You can't see the violet colors. Correct. If you see from your house, you just take the top of the roof of the building, and if you see from the tower, if you see any cell tower, you can see the red lights on the top of the cell towers. You can't see any other things of the cell towers. The red light is having more wavelength. That is the reason you can able to see. It does not illuminate, but you can able to see from wherever you are. Got it? What I'm saying?
Yes, sir.
So these are the some kind of practical questions they might be asked in examinations. I'm talking about little bit higher level, like tough questions I can say. Next one is, what are the factors affecting from this discussion? How we can explain that question? Or okay, before going to that question, what is the conditions for a light ray to pass undeviated? When we can say the light ray, suppose there is a medium 1 and medium 2, and I'm sending a light some angle. I'm sending from 0 degrees to any angle up to 90 degrees. When the light ray will be undeviated? When the light ray is undeviated? Anyone? When the light ray was undeviated? Any answers? Anyone hearing? Question came. So 3 marks question. 1.5 for each. There are actually 2 conditions. Only at those 2 conditions, light ray will not deviate. At least one answer I'm expecting from you. At least I will show a table which will show. Yeah.
Sir, if the refractive index of two mediums are equal, then
Correct. If the refractive index of 2 mediums are equal, automatically we can say
then the light is undeviated.
correct. The light is undeviated. Just I will show a small table which will shows the refractive indices of different mediums, absolute refractive index of different mediums. As she said, the first condition is see, by looking into this table, these are the different mediums where the different refractive index. For vacuum it is 1, air it is 1 almost. That's the reason we are considering air or vacuum, because the air is 1.003. So when it comes to ice and water, almost same, 1.31 and 1.33. Methyl spirit 1.36 and ether also 1.36, alcohol 1.37, kerosene 1.41. So different mediums you can see. But if you see glycerin and turpentine oil 1.47. Suppose if I am taking the two mediums of glycerin and turpentine oil, this is a glycerin, this is a turpentine oil. So even though if it is two different mediums, the light ray will undeviate. Here your sin I will be equal to sin R. So the first condition is refractive index of medium 1 should be equal to refractive index of medium 2. This is the first condition for the light ray is not to deviate. The second condition is if the incident angle is 0 degrees. What I'm saying? If your I is 0 degrees, that means, see, the blue color says the incident ray is like 0 degrees. It is, if the light is coming like this, even whatever the medium you take, this is air and this is any medium of any refractive index, the light ray will undeviate. Even if this is refractive index is 1 and this refractive index is 1.45, or if this refractive index is 1.5, or this refractive index is for a diamond, the refractive index is 2.41. So if the angle of incident is 0 degrees, see here the angle between the blue color line says incident angle, the red color line says sorry guys, yeah, this is normal. The red color line shows the incident line. So if the angle between the normal and the red color line is 0 degrees, after refraction also it will be undeviated. So these are the this is the second condition, the where the light ray is undeviated. Is it clear what I'm saying, guys?
Yes, sir.
Now, how many people know the idea of principle of reversibility? Principle of reversibility. Anyone can able to recollect? Anyone can able to recollect? Anyone can able to recollect principle of reversibility?
Left appears to be right and right appears to be left.
No. Yeah, so I will play video. After that you can discuss. It's a 2-3 minutes video. After that we can see, like just anyone can able to explain again, you can explain. Just share your computer sound. Yes. If you are unable to hear audio, please let me know, guys.
Principle of reversibility of light. Consider a ray of light going from air to water. So, it bends towards the normal. So we can say in this case this can be considered as angle I, and this can be considered as angle R, because this is the normal at the point of incidence. Now, when a plane mirror is put inside water, in such a manner that this light ray is incident normally on it, then what happens? It will retrace its path. Again, when this light ray strikes the interface, now this is going from a denser medium to a rarer medium. So, it will bend away from the normal, along the same path it came. This is the principle of reversibility of light, that states, if the path of light is reversed, after suffering a number of reflections and refractions, then it retrace its path. This is known as principle of reversibility of light. When light ray enters from air to water, because we have to define the refractive index of the two mediums, so the refractive index of air we can taking it as mu1. The refractive index of water can be taken as mu2. So, if we apply Snell's law when light enters from air to water, what we can write, sin I upon sin R, is equal to refractive index of water with respect to air. That is mu2 upon mu1. Also we can write it as 1 mu2. And, after reflection, when light ray enters from water to air, now, in this case the angle of incidence will be R, and the angle of refraction will be I for the return path. So what we can write in Snell's law, we can write sin R upon sin I is equal to refractive index of air with respect to water. Because we always write refractive index of second medium with respect to first medium. So for the return path, the first medium is water and the second medium is air, so sin R upon sin I is equal to mu1 upon mu2. That we can write it as 2 mu1. Taking these as equations 1 and 2 and multiplying them, we can write sin I upon sin R multiplied by sin R upon sin I is equal to 1 mu2 multiplied by 2 mu1. So from this, sin R gets cancelled out from numerator and denominator. Also sin I gets cancelled out from numerator and denominator. And what we get is 1 mu2 is equal to 1 upon 2 mu1, because sin I gets cancelled out, sin R gets cancelled out. So we can write this expression. 1 mu2 is equal to 1 upon 2 mu1.
Is it clear, guys? What is the meaning of principle of reversibility? From there, what we can give a conclusion? Suppose if I am saying sorry guys, will you able to hear me now?
Yes, sir.
Pujita, can you make me as a host? Yeah. What principle of reversibility says, suppose if light ray is entering from air to water, it's like this. Here we are discussing refractive index of air with respect to water. Sorry guys. It's the refractive index of water with respect to air. So This is, suppose if I'm
not sharing a screen.
1 second, guys. Sorry. Yeah. Now, suppose the angle of incident is 30 degrees. The angle of refraction is some 24, 25 degrees. For example, it's not an exact case. If the light ray is entering from water to air, I am giving in such a way the angle of incident is 24 degrees. It will give exactly the angle of refraction is 30 degrees. Here, refractive index can be defined as refractive index of air with respect to water. The relation between these two refractive indices is, according to principle of reversibility, refractive index of water to air will be equal to 1 by refractive index of air to water. This is only one point you have to keep it in mind, other than activity. Is it clear, guys, what I'm saying?
Yes, sir.
See, only a major part remaining from this is ray diagrams. Straight questions will be expected from the ray diagrams. If there is any doubts, please send some messages. Based on your messages, I will conduct one more class before the examination. Please prepare for your exam. Shall I wind up the class? Guys, shall I wind up the class? Any doubts need to be discussed?
No doubt, sir.
Having any doubts, please let me know.
Good, sir.
We'll meet in next class. Bye, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.